Okay, so next is question number 26 and an algebraic fractions question. So first thing we need to do to solve this is we want to factorize everything and see what we can kind of cancel out. So otherwise, if we try and do this in one go, we'll end up quite a complicated equation. So if we start on the left-hand side, we've got 4x squared minus 17x minus 15 over 2x minus 1. So 2x minus 1, okay, is going to kind of state how it is. And then we've got the top. So this is kind of a bit more complicated to kind of factorize. So if you weren't sure how to do that, you could use a quadratic formula. But if you ever think, so we've got 15 at the end, and it's minus 15, so we're going to have positive and negative. So it could either be like 5 and 3, or it could be 15 and 1. Given the other numbers, it's more likely it's going to be the 5 and the 3. Okay. So if we think of 5 and 3 there, we don't quite know which way around it's going to go. But if we think of 4x squared, again, that can either be 1 and 4 or 2 and 2. Okay. If we think about what it could be, if we want to make minus 17x, we've got a 5 there. If we have 4x and we have x, then the 5 times 4 is going to be 20x, 3 times the 1 is going to be 3x, and then we can get the minus 17 from there. So we want minus 5 and then positive 3. And again, if we weren't sure, we could check it as well. And then if we factorize the next bit, the denominator is probably the easiest bit, x squared minus 25. That is example as a difference of two squares. So that is going to be x plus 5 and x minus 5. Okay. And again, we can, if we look already, we can see some bits are going to kind of cancel out. If we try and factorize this, one thing that I would kind of think about is we know we've got a 3 there, and we've got to get 2x squared. Looking at the other denominator, we've got 2x minus 1. It's likely that 2x minus 1 is going to also appear in the numerator here, so we'll be able to cancel those out. It's not kind of definite, but it's a good kind of thing to try, especially if you're not sure. 2x minus 1 there would give us x minus 3. So if we see if that would work, 2x times x is going to give us the 2x squared. Minus 3 times minus 1 is going to give us the positive 3. Minus 3 times 2x is going to give us minus 6. Minus 1 times x is going to give us that. Okay. And then we've got. So now if we look what will cancel out, we've got x minus 5 and x minus 5. 2x minus 1, 2x minus 1. Okay, so that's going to give us 4x plus 3, x minus 3 over x plus 5 plus 29 minus 4x. So because this is addition, same rules apply as normal kind of fractions. We need a common denominator. Currently, if we imagine our denominator is 1, okay, that helps us to kind of see. Our common denominator, we can make it x plus 5. So the first fraction is going to stay how it is. And then to get a common denominator, we need to have the top and the bottom by the same thing. So we've got those bits there. Okay. Then to add these together, if we think about expanding all the brackets, well, from the first one, we're going to get 4x squared from the 4x times by the x. We're going to get minus 3 times 4x, so we're going to get minus 12x. 3 times x is going to be 3x. Okay, and then we're going to get the 3 times the minus 3 is going to be minus 9. Okay, then in here, if we look what we're going to get, we're going to get 29 times x is going to be 29x. Minus 4 times x is going to be minus 4x squared. Minus 4x times by 5 is going to be minus 20x. Okay, and then we've got the 29 times by the 5 is going to be 145. Okay, then if we just add them together, kind of term by term, 4x squared plus minus 4x squared, that's going to disappear. Then we've got the minus 12x plus 3x, and then minus 20x plus 29x. That's going to disappear because we've got minus 12 plus 3, that's going to be 9x. And then this term and this term is also going to be 9x, so they're just going to disappear as well. Okay, then we've got minus 9 plus 145 is going to be 136. Okay, so then we've got 136 over x plus 5. When we get to this point, it's always a good idea to kind of factorize the top and the bottom, see if we've missed any simplifications at any point. But given that we've only got a number at the top, then it means that this is going to be in its simplest form because we've only got a number at the top and we've got no coefficient with the x. So that means that this would currently be in its simplest form. I would finish that.